Hello there, that's KP the Math G once again. Hey, all in the same day. Now it was like 2 or 3 days before I've done another video, and now here I am doing yet another video today. Now, if you saw the last video, I made an error, and I left this up here. I put it in my comments what the error was, but I want, in case maybe you didn't get a chance to read my comment below the video, or this is the first time you're seeing this, do you see the error here? Okay, and I don't want to be wrong, but I was wrong. I was incorrect on this video here. Well, not on the entire video, but just on this problem. I did 3 problems and I was incorrect on this one alone. But where's the error? Notice I let u be 3 theta. That's okay, right? du was 3 d theta, okay? And then 1/3 du, I multiplied both sides by 1/3 and got 1/3 du is equal to d theta. Great. But look at my final answer. Look what I did when I integrated. Where's the 1/3? So what I should have done, everyone, boys and girls, men and women, I should have put 1/3 right there and made this equal to, oh yeah, that's so much better. Okay, there we go. We do know that the antiderivative of sine is cosine, actually negative cosine, okay, but I needed a negative 1/3 out here from the very beginning. So that, I just wanted to show that quickly. I'm going to try to do some problems here, and hopefully I won't make the same mistake that I do. And usually if I do, I will put it in my comment. Every time I do that, I will make a comment. I always look at these videos myself one time, and then I want to make sure I didn't make an error. Okay, but I caught it this time, and this is actually the first time that I made an error like this before. Okay, alright, so let's erase this and let's move on now, okay, to some other stuff. Now, let me rewrite this. I've got part 2 written here. That also now is part 3. So let's erase that 2 right there. And let's get the same color I had from stock. And let's put down part 3. Alright, and I was saying that the integration gets a little more involved, so that's what I'm doing here. And in this video, I'm combining e to the x with sine, cosine, and tangent. Alright, so I want us to be aware that we can do that. So let's begin. I had a different number 1, so I'm going to make my number 2 a number 1. So, alright, so I'm going to integrate here. We'll say e to the cosine pi x sine pi x dx. Okay, this is my first example. What to let u be? And we are doing this by substitution. When do you know you need to substitute? Well, one thing I know to do is I've got cosine and sine. It would be nice that in my substitution I get sine pi x dx back. Anytime you have this as an exponent like this, like we've done before, or in other examples before where well, maybe I had like a cube root. If I had a square root or a cube root or a fourth root or a fifth root of cosine pi x and then sine pi x dx right here, I'm going to let u be that. Alright? Okay. If I have something to an exponent with, as long as I have cosine and sine or sine and cosine, either way, whatever is the exponent or whatever, in this case cosine pi x is the exponent, so I'm going to let u be that. Alright, and then you see what you're going to see what's happening. So I'm going to let u be equal to cosine pi x. Alright, let me make sure this is right. Okay, now the derivative of cosine though is negative sine pi x. Now remember, we have the chain rule, so we have to take the derivative of pi times x, which is just pi. Let me scoot my du over. I'm just going to need a little more room on that. I'm sorry. Just need a little more room here. Du is equal to, okay, so I'm going to leave a little space here because I'm going to need it. I'm going to put a negative sign and put a blank here. The negative is because the derivative of cosine is negative sine. Negative sine pi x. Now remember, I need to do the chain rule, okay, of this pi x right here. Okay. Well, let me just do it this way. Negative. I'm going to get it right, boys and girls, men and women. Negative sine pi x. Now, I'm just going to leave it like that. Now times. Now I want by the chain rule, I'm taking the derivative of pi x. Well, pi is a number, so the derivative of a coefficient beside a variable is just that, isn't it? Pi dx. Now, do I have it all? Well, I've got too much actually. I've got a negative sign for one thing, and I do have sine pi x right here, and I do have dx. So right now I have this, and I have this. And I've got a little too much here, don't I? Okay, so let's rewrite this. Du is equal to negative pi sine pi x dx. Okay, man alive, I have that right here, don't I? I have that, but I have this also. So remember, when you have too much, it can't be a variable, it can be a coefficient or whatever, but I can simply get rid of this by multiplying both sides by negative 1 over pi. Okay, multiply this side by negative 1 over pi. What happens is, this is over 1, and the pi's divide out, the negative signs also, and everything divides out here, and you're still just left with negative 1 over pi du is equal to sine x dx. Oh, sine pi x dx. I'm sorry. Okay, sine of pi x dx. And look what I have here. That's what I have. When you make that substitution, you cannot leave the negative sign here. You can't leave the negative pi here. You got to get this over on the other side. And it's not enough to just get the divide by pi or multiply by 1 over pi. You got to get that negative sign over there too. Okay? Because you don't have negative sign here. Okay? So you want this side here to be that catch-all, where you catch all this and have what you want over here. And we got what we want right here. Alright, so now when we integrate, I'm not going to make the same mistake that I made in the last problem. Now let's see. I have got this, and before I start, I'm going to go ahead and put that negative 1 over pi right there. Ooh, I'm not going to forget that. Okay. Now I've got u is e to the u. So e to the u du. Jiminy Cricket, this is an easy one because I know that whether it's a derivative or antiderivative, either way, the antiderivative of e to the u is e to the u. The derivative of e to the u is e to the u. So this answer is easy. So I've got my negative 1 over pi. Don't forget that. E to the u plus c. And I don't guess I need this bracket here. Okay. That's it. But now, u is cosine pi x, isn't it? That's what I let u be. So let's substitute that back in there. So now we have negative 1 over pi e, find out what u is, cosine pi x plus c. Always go back. It's good to say this is what I let u be, because some people put sine pi x here when it should be cosine pi x. Alright, so what we had was e to the u du. You see that? Okay, that is what we have. And then now, I didn't make the same mistake that I made last time. As weird as that answer may be, that is the final answer here. Okay? Alright, well, that's the difference in part 3 and part 2. Okay, last time I just had cosine and sine. Now I've got e involved here. Alright, so that's what I've got on this one. The second problem, let's just go ahead and flip the board over. I've got to pull it out because I've got a bed behind this, and I got Christmas stuff on my bed, boxes and everything. Alright, actually everything's been wrapped and they're in a box. I'm ready for Christmas to start. I've had stuff wrapped for quite a while, and now it's just a matter of well, waiting for Christmas to come, pass it all out. Alright, so let's do another problem. This was going to be problem number 1. Yeah, I have several pages of this here. I do. Okay, I want to go ahead and do this one. Let's do this one. I could make it the third answer, but I mean the third problem. But we're going to go with this one. This was number 1 from the start. 4e to the x minus 4e to the negative x dx here. And this is e to the x plus e to the negative x. Okay, like that. Okay. Alright. Oh, and this was squared. I knew now why I put that in parentheses. Okay, now do not, I repeat, do not square this binomial here, because I'm going to let u be equal to whatever. They say, okay, which one needs to be u? Usually in this case, when you have a numerator and a denominator, you usually going to have the denominator be u. And the thing is, this has an exponent here. So what did I say? Last time anytime we have a problem, it's got an exponent or a square root or a cube root or whatever, or e to that, that's what we're going to let u be. Okay? Like in the last problem we had e to the cosine, whatever we had just now. Alright? I think it was e to the cosine pi x sine pi x dx is what it was. I believe it was. So I'm going to let u be equal to, alright, this is an x here, e to the x plus e to the negative x. Okay, do not put that in parentheses and let that be this squared. You don't want to do that. Just let u be that right there. Okay? Incidentally, let's rewrite this problem because I rather would have this in the numerator, but for right now I'm going to keep it in the denominator for emphasis. I'll show you why I want to do it that way. Now let's look at du. Du, that's the derivative of u, this du, derivative of the left side. What's the derivative of e to the x? It's e to the x, isn't it? What's the derivative of e to the negative x? It is e to the negative x times negative 1. Okay? So if we wanted to do this plus, okay, if we want to do it that way, we could. Because remember, the chain rule says we got to take the derivative of e to the u. Well, e to the u is e to the u. That in this case is negative x. E to the negative x times the derivative of negative x is just negative 1. But negative 1 times this is, I can just make this negative, put that negative as a minus sign right there. Or I can put it in front. Alright, so du is equal to e to the x plus negative e to the negative x. I just don't have the 1 here. But what's plus a negative anyway? Look at that. Plus a negative is just simply minus. Now, yeah, granted kp, oh, by the way, dx. Well, kp, the math g, you don't have it. You don't have a 4 e to the x minus 4 e to the negative x. But what do I have? Get another color. I do have e to the x minus e to the negative x, don't I? So I could actually rewrite this numerator right here by taking out a 4, can't I? Oh yeah, I can take a 4 e to the something power, or e to the negative x, or e to the x out, but I don't want to do that. I'm going to take out the 4 because I already got e to the x minus e to the negative x dx. I have what I'm looking for, really. Alright, so if I do this and take out the 4, I'm actually going to put this out in front. Let's get red. Okay, that's a little more visible. I'm going to put the 4 out in front right there. Okay? I can do that. That's just 4. Alright, I'm taking that 4 out. And that is going to leave me with e to the x minus e to the negative x. And look at this numerator. This is actually a numerator also. This is dx here. Alright, over. Alright. Over e to the x plus e to the negative x squared. Okay, I just rewrote this top. That's all I did. I just took out the 4 right here and just rewrote the entire problem. Okay, but now notice right here, get yet another color. What do I have here? Right here, e to the x minus e to the negative x dx. I have this right here. Oh my goodness, yeah. After I factored out that 4, I do have this after all. So, we are at the point of setting this up. Let's put the 4 down. Okay. Let's put the 4 down. I'm going to integrate. This is du, isn't it? Du over, now this is what? What did I let u be? E to the x plus e to the negative x, didn't I? Well, that is u squared, isn't it? Now, this is not an LN solution. Why not? Pray tell, why not? Because this is not an exponent of 1, it's an exponent of 2. Well, how do I do that now? Alright, let's be reminded. This is a recall. Alright, I'm recalling. 1 over a to the n is equal to a, brought up in the numerator, to the negative n. So I'm going to rewrite this with the 4 in front. I'm going to put 4 in front. Okay, so bring this up here. That's going to be u to the negative 2 du. You see that? Alright. Look at that. I've just brought it up. That helps things. Now remember now, I can take the, when I take the integral of u to the negative 2, I'm adding 1 to that, which is going to be u to the negative 1 over negative 1, like that, isn't it? Negative 2 plus 1 is negative 1. Alright, don't forget you do have a 4 sitting out here, so don't forget that, like I did in the last video. Alright, so now I've got u to the negative 1 over negative 1 plus c. Okay. Okay. Now, well, I'm not done yet. All these little preliminaries that I have to do, we have to take care of the these little u's. We got to substitute that, and I can rewrite this in so many different ways. Can I not bring the negative 1 here? This is actually 4 over 1. Can I not make this 4 over negative 1, which is just negative 4? So can I not just do this and make this negative 4? Still, I got u to the negative 1 plus c right there, don't I? Okay, and actually if you want to, you can put the plus c on the outside. It does not really matter. It's just a general constant is what it is. Alright, now u to the negative 1. Alright, I'll let u be e to the x plus e to the negative x, didn't I? Alright, so this is negative 4 times e to the x plus e to the negative x. Alright, that's an x there. Okay. Pardon me on that one. Negative x. Alright, and then plus c. Oh, this is to the negative 1 power. Okay. And remember now, if I have a to the negative n, that's 1 over a to the positive n. So since all of this part right here, put a different color, this part right here is the only thing I moved down. And I have a lot of students who will move the negative 4 down too because the 4 is negative. But this is not an exponent. This whole thing is raised to the negative exponent. So I'm going to leave my negative 4 up here. So this is equal to negative 4 over e to the x plus e to the negative x. Now that's raised to the positive 1 I don't need that though, do I? Okay, and then now plus c. And there it is. A little bit of work, huh? This takes a little bit of training your eyes to see. First of all, maybe you could just factor out the 4. And if you factor that 4 out, you're left with e to the x minus e to the negative x. You are hoping that if you let this portion be u, not the whole thing, do not put the square involved in the u. I used to do that when I took calculus 2. Don't do that. Just u is what's inside the parentheses. Then I found that du happens to be the same thing as this on top with the 4 factored out here. Okay? Alright. Why is this not 1/4? Because we factored out the 4 in the first place. Okay? If we had did a 4 here and then we brought it to the other side, it would have been a 1/4 du. If that had been over here when doing this, but it wasn't. We just went ahead and factored it out from the start. Okay? So, yeah, this is a pretty nice little problem here. It's pretty involved, isn't it? Okay? Alright. That is that portion there. Maybe I can flip this over. And yes, from the last few videos, I have been losing this, and I tell you what, I'm going to leave this out because I found my glue. I'm going to glue that thing back in, but I'm going to wait till after the video's over to glue it back in. Okay. Oops. Let me pull this back. Gotta remember, I got boxes behind me. Okay, back to that problem that I corrected at the beginning of the video. I'm going to erase this. Okay. And we're going to do one more problem. Hopefully we have time for one more. My wife is patient with me. She lets me do this, and I could be spending a little time with my wife, you know, just a little bit. But she's getting ready to go to church tonight. I'm already ready to go. So I went ahead and decided to dress early so I could do a video. Alright, now let's do one more problem. Oh yeah, I can't connect that. I don't have enough magnet on this. Alright, so now let's do one more problem. Alright, what is this? Actually, it's similar to a problem we did from the last video, but we're going to do it again. It's good to practice. E. Now look here, I'm raising something up right here. Alright, that is going to be u right there. Now, I already have an exponent. That's going to be, I'm going to go ahead and write that down. U is equal to tangent of 3x. I already know that. Well, maybe so, provided that I have a secant squared sitting out here, and I do. That is actually part of the problem. Secant squared 3x dx. Okay. Now, look, guys and girls. Guys and girls and no squirrels. Okay, we don't have any squirrels, and they can't pay attention anyway. Du, the derivative of the left side, du. Derivative of the right side is, whoa, what's the derivative of tangent? Secant squared, aha, secant squared 3x, chain rule, times 3, Okay, alright, the derivative of 3x is 3. And then dx. Yeah, the derivative of x is just dx. Well, do I have everything here? I have, let's see what all I have. Secant squared 3x dx is what I need to have. Secant squared 3x dx. Oops. I have too much. But remember, oh yes. Remember, we can multiply both sides by 1/3 and get rid of this here. So, oh, if I can just multiply this times 1/3 and this side by times 1/3, I have 1/3 du is equal to, now watch this now, erase the oops, we don't need oops here. I have secant squared 3x dx, because see these 3's are going to divide out. And I got my 1/3 over here.